Hello, today we are starting the introduction to statistics. So 9.1 is going to cover statistics, vocabulary, and the measures of central tendencies. Statistic contains a lot of vocabulary, so below are some words that we need to know. Statistics is the art and science of extracting meaning from data. A census is acquiring data from an entire population. Sampling is polling of a small portion of the population, which is intended to show what the whole population is truly like. And there are many different types of sampling that we are going to do. We are going to talk about 7 particular types of sampling. The first 4 are the ones we want to try to use every time. The last 3 we only want to use when absolutely necessary because they don't give us the best information. Random sampling is every possible sample has an equal chance of being selected. And this is an ideal situation. Okay, this is what we want to happen every single time. Put all the names in a hat, pick out a name, those are the ones selected. It is completely random. Systematic sampling is a random sample, so that's why this is okay, that is chosen in a specific order. Okay, you have a system in place to pick these people. You're going to pick every 10th person that walks through the door. You are going to start at number 5 and then every 4th person after that. Stratified sampling, this is another form of random sampling, and it is a random from a group or a subgroup to obtain a particular type of the population. For example, I want to know something about graduation, so I am only going to ask the seniors because they're the only ones that are interested or have any interest in what I'm talking about. And the third type of random sample is multi-stage sampling. This is a random sample from specific clusters of a population. So, for example, if I want to find out about how people feel about a new law that is about to come into place in Michigan, I'm not going to ask the people of Washington to weigh in on it. I'm only going to focus on the people in Michigan and then go from there to see what they think about it. So now we are on to the sampling that we absolutely do not want to do unless we have to. Bias sampling is something that we never have to do and we never want to do it. It is some possible samples may have a preference for a specific outcome. So I'm going to ask a group of people that I know they agree with me, and therefore, when I look at my survey results, it's going to tend to go one way instead of having a completely random sample. So we never want to do bias sampling. Voluntary sampling, and this is possible samples choose whether or not they participate. Now, this is necessary, this one. If you are in a medical trial, you can't force people to participate on a medical trial. They have to choose to do it. So it's not something that you can say, I want to pick every fifth person that walks through the door, because they have to agree to participate because they are taking things into their body. Convenient sampling. This is most possible samples are self-selected because they're the easiest. Okay, I want to find out, what people in Asheboro think about a certain topic. So I'm going to go stand outside my local supermarket and ask them because that's closest to my house. That is convenient sampling. Am I going to get the entire city population of where I live? No. But it's easiest for me. So when we look at statistics, next we need to talk about the variables. So there are going to be two different variables that we look at when we talk about statistics. So a variable is the data collected on each subject is broken into two different types. Categorical, this is a variable that is assigned a characteristic of each subject or group. Okay, this would be a thing. So, for example, eye color, or gender, or your favorite music. Those are all characteristics, so those would be categorical. Quantitative is a variable that is assigned a numerical value. So it's going to be a number. That is, again, a numerical value of each subject or group. So this could be your height, your weight, your shoe size, your favorite number, your age, your salary. Anything that has a number will be a quantitative, and anything that is a thing will be a categorical. So if we want to get some statistics and find some information about a population, we have to decide how we are going to get that data. So that is where sample design comes into play. This is the choice and the specifics of how a researcher will collect data. And there are 4 different things that we're going to look at. Observation is the researcher watches responses and tries to avoid influencing the subjects. So if you are going to do an observation, you are just going to sit back and watch. I want to see what the hottest toy for Christmas is going to be this year. So I get a bunch of 8 to 10-year-olds and throw a bunch of toys in the middle of the room and say, go play. And all I do is I sit back, watch, see what happens, make notes of what they want to play with. I am at no point in time going to go up to any child in there and say, hey, you want to play with this toy? Or what do you think about this one? All I'm doing is sitting back, watching what happens. Another way is a survey, and this is where the researcher poses questions and records the subject's responses. And everyone is pretty familiar with surveys. We do them a lot. I ask a question, you answer it, I write down your response. An experiment, The researcher intentionally imposes a treatment upon the subjects. Okay, so this isn't necessarily a experiment like you may do in science class. Okay, so this experiment has to have two groups. It has to have the control group and the treatment group. So the control group is someone that, or the group that might get, if it's a medical trial, a placebo drug, a sugar pill, or whatever they're going to give. It looks just like the actual product, and they don't know they're getting the one that isn't, because that could impose judgment or lead to them really believing it doesn't work or it does work based on whether they think they really have it or not. So the control group, the placebo group, gets something. They either get the current treatment they've been doing or something like that, or a sugar pill. And the treatment group gets the new drug, gets the new medicine, gets whatever we're looking at. Okay, so you have to have two groups in an experiment. And the best way to do this is a double-blind study where even the researcher or the doctor does not know which medicine which person is getting, because that way they cannot unfairly influence them without even realizing it. So the only one that knows which person in the experiment gets which drug is the one back in a research office somewhere. So the nurse doesn't know, no one in that facility knows except for the person behind the computer. And finally is a simulation, and sometimes you have to use simulations because it's not ethical to do otherwise. And this is where the researcher uses a math model and probabilities to examine outcomes. So let's take a look at some examples. So in example 1, we're going to see, are they random samples? So random samples are ideal. Remember, those are the best. And determine if each method produces a true random sample. So asking every 10th person coming out of a health club how many times a week they exercise to determine how often people in the city exercise. So this is not random. And that is because if you are coming out of a gym, you are probably doing it because you were in there exercising. So this would either be biased or convenience. Okay, if you want to know how many people in the city exercise, you can't stand outside of a gym and ask them. You gotta find somewhere else to go. B, surveying people going into an Italian restaurant to find out people's favorite type of food. This is, again, not random. And this is probably biased. If you are going to an Italian restaurant, you probably like Italian food. So that is not the place to decide whether or not, or ask people about their favorite type of food. C, a government sending a tax survey to everyone whose social security number ends in a particular digit. This is completely random. If it had been starts with a particular digit, that is not random. The first 5 numbers of your social security number give information about where you were born, your last name, and that sort of things. The only ones that are completely random are the last 4 digits. D, surveying students in an honors chemistry class to determine the average time a student in your high school or in your school study each week. This is, again, not random. If you are in an honors chemistry class, you are probably studying a little more than someone in, let's say, let's say gym class. Okay, if you're taking honors chemistry, you need to do a little more studying than if you were in gym class. So what I want you to do, pause the video right now, try these last 3 on your own, decide if they're random or not random, and if you can come up with what type they are. So this D would be biased or voluntary. So hopefully you were able to pause it and figure these out. So let's go over them. E, putting names of all seniors in a hat, then drawing names from the hat to select a random sample of seniors. This is random, and it is stratified. Okay, there's a systematic, this is the subgroup. So I don't want all the kids in the school. I only want a specific group of them, the seniors. F, selecting a student from 200 by picking the 5th student, then every 10th student after that. This is random. And this is systematic because there's a system in place for figuring out what it is or how they're getting them. And G, selecting a resident of the United States to take a survey by choosing a state, then a county, and then a city. So this is random, and it is multi-stage. So now let's take a look at example 2. It says, determine what type of sample design is being described. So this is where we're talking about observation, survey, experiment, or simulation. A teacher wants to make sure a pair of dice are fair. One side is not weighed more than the other by rolling them 1,000 times. So this is a simulation. Anytime you do anything with dice, it is a simulation. A doctor is monitoring a patient after they have administered an injection to see if the patient has a reaction. This is just an observation. Okay, they gave the injection, now they're sitting back watching, making sure nothing happens. This happens when people go get allergy shots every time they go into the office. They get the shot, then they have to sit in the waiting room to make sure they don't have a reaction. C, a manufacturer asks random people in a town what products they would like to see sold in the area. And this is a survey. Just asking a question, writing an answer. And D, a fitness instructor gives out an herbal supplement to her students to see if it enhances their performance. So this is an experiment. Okay, she is giving them something to take, to ingest in their body to see if it changes anything. So let's talk and review the measures of central tendency. So a huge part of collecting data and interpreting is finding the measures of central tendency. So the measures of central tendency represents the center or the middle set of the data. And we have done these, you've done them since 6th grade, so this is just a review. Your mean, median, mode, those are your measures of central tendencies. So your mean, remember, is the sum of the numerical observations divided by the number of observations. So what I want you to remember about this, just remember that it is the average. Okay, we add them all up and we divide by how many there are. That is average. So a common notation for this is x with a bar over it, and we call that x bar. Okay, and you see that when you do the one variable statistics on your calculator when we put them in. Okay, don't worry about this part. We're not going to go over that. So the median, after arranging the numbers in order from least to greatest, and this is the biggest mistake I see people making, is you don't put them in order. You cannot find the median until you put them in order. It is the middle number. If there is an odd number of data points, you're just going to take the middle number. If there is an even number of data points, you are going to take the average of the middle two numbers. And finally, mode represents the number that occurs the most often. If there is no mode, or if no number occurs more often than any number, in other words, every number occurs one time, the data is said to be amodal. If there are two numbers that occurs the same number of times, then the data is bimodal. So you can have more than one mode. You can only have one mean, you can only have one median, but you can have more than one mode. So we are going to look at finding the measures of central tendency. You will need either your calculator or Desmos to do this. So with this first one, I will show you how to do it on your calculator. So to find the measures of central tendency, to do this, we are going to go to our list. So just hit stat and hit enter on edit. And now we are going to type our numbers in from our list. So once I have all 10 numbers into my list, we are going to go back to stat. This time we're going to arrow over to calc, and you're going to hit enter on one variable statistics. You're going to hit enter all the way down to calculate. And it gives you everything you need. This right here is your mean. If you arrow down, we have our median. The only thing it does not give you is your mode. So to look for the mode, you're going to go back to stat, and this time you're going to sort A, and you're going to hit second one and enter. Now if I go back to my list, stat, edit, you'll see all my numbers are in order. So I can see there are 2 75s and there are 2 92s. So those are both my mode. So from our calculator, we had that our mean was 84.6. Our median was 84.5. And our mode is 75 and 92. So now we are going to do, I will do B with you using Desmos, and then you can pick which one you decide to use. So for Desmos, we are going to hit this plus sign. You're going to come down to table, and you're going to enter your data points just in your X column. So in this case, this is what we call over here a frequency table, which means 0 job offers happen twice. So I'm going to put 0 in twice. 1 job offer happened twice. So 1 gets put in twice. 2 job offers happened 4 times. So 2 gets put in 4 times. 3 happened 5 times. So 1, 2, 3, 4, 5. And 4 happens twice. Once you have your data in your table, then I can type just mean, parenthesis, and I want the mean of my X1. Because X1 was the list I just put it in. So there's my mean. I can do the same thing for median. Parenthesis X1, and you don't have to do anything to get a subscript. Oops, hold on. Hold on, let me fix that. Okay, so let's try this again. Not sure what happened there. It's median X1, and it was 2. Mode, you can clearly see from the frequency table, 3 occurred the most. It occurs 5 times. So my mean is 2.2. My median is 2. And my mode was 3. So on your assignment today, pick which one you like to use. You can use your calculator, you can use Desmos, you could use both. It's whatever is easiest for you. So let's go on to our last thing, which is our box and whisker plot. So a box and whisker plot is a type of quantitative data display that is organized around quartiles. So this is breaking everything up basically into quarters. And shows the spread, your min, max, median, range, outliers of the set of data. So remember, your minimum number is your lowest number. And both Desmos and your calculator can get all of this information for you. Your maximum number is your highest number. Your lower quartile, or your Q1, is the median of the lower half. And your upper quartile is simply the median of the upper half. And this is your Q3. And your interquartile range, or your IQR, that is simply the range of the middle half of your data. So to find it, You always take your Q3 and you subtract Q1. An outlier is an element of a data set that is at least 1.5 times the IQR, less than Q1, or 1.5 times your IQR greater than Q3. So to figure these out, we need to be able to calculate lower and upper bounds. So our lower bound is going to be Q1 minus 1.5 IQR. And your upper bound is going to be Q3 plus 1.5 times the IQR. And any data that is not between the lower bound and the upper bound is an outlier. So your outlier is simply a data point that doesn't fit with the rest of the data. It is too far removed from it. So let's take a look at example 4, and I'm going to go ahead and do this on Desmos because I think it's simpler that way. So let me pull that up. But you can do it on your calculator if you want. So in Desmos, we are going to start with the same thing we did for median, and mode. We are going to go ahead and insert a table. Again, we are only going to type the numbers into the X column. So even though the table is 2 columns wide, we are just going to continue with the next column right onto this one. So the last one in the first column on your paper is 99. The top of the second column is 95. We're just going to keep going down as if it is one list. It is one list. I just ran out of room, so I had to put it as 2 tables. Once we have our data points, now we're going to get our information. So I need my minimum. So I type min and then X1. It'll automatically subscript it for you. Okay, I'm going to type the maximum X1. Oops, sorry. Maximum X1. To find your quartile or median, just type median X1, just like we did before. Okay. To find your quartiles, you're going to type the word quartile. You're going to then type your list, so in this case X1, and then which quartile you want. I want quartile 1, and I want quartile for X1. So quartile 3, hit enter. I can also get a box plot. So box plot X1. And notice over here, and I played around with the zooming in and out till I could get my picture. Notice over here my box starts here at 66. And it doesn't start at 42 like my minimum said it was up here. That is because there's a dot at 42. That means 42 is an outlier. And we're going to go and I'm going to show you how we calculate that in just a second. So I have a dot for my outlier. So on my paper, I need to change my minimum to 66. So when we have an outlier, we have to throw that out and find the next lowest number. So my picture, a dot for the outlier, a dot for the minimum. My bar is for Q1, my median, Q3, and another dot for my maximum. So let's go to the paper and draw this out. So we found our minimum was 66. Our maximum was 99. And that's because 42 was no longer our minimum because it's an outlier. Our median, that doesn't change, is 86.5. Our Q1 was 73. Our Q3 is 90. So to find the IQR, I take 90 minus 73. Punch it in your calculator, you'll get 17. So to check for outliers, I have to find the lower bound. So from my formula up top, it said take Q1, so that's 73, minus 1.5 times my IQR, which was 17. We type that in our calculator, we get 47.5. I have to find my upper bound. So that is my Q3, which is 90 plus 1.5 times 17, which gets me 115.5. So all of my data should fall between these two numbers. If it doesn't, it's an outlier. So in this case, do I have an outlier? Yes, it's 42. That 42 lies outside of my data set. So when I come up to my box plot, so I'm going to do each of these lines is 5. I'm not going to mark every line. So I will always put a dot for my outlier. And then I'm going to put a dot for my minimum. My bars are for my Q1, my median, and my Q3. And that's what I connect with my box. And my maximum is another dot. And those dots are connected by the lines. And there's your box and whisker plot. Again, I will link separate videos on how to do this information in both your calculator and Desmos. So if you need to see just those videos, you can go and do that. But if you have any questions, let me know. Thank you.